Servers are everywhere and they are key infrastructure elements to host workloads. Server security is crucial because servers are the backbone of your organization's digital infrastructure, responsible for storing, processing, and managing critical data and applications. When it comes to server security, there are 9 different categories that you must ensure that fulfilling required controls. This looks a heap, but let's understand in depth because servers are reality of the digital world. You can see the 9 different categories on the screen, and let's discuss the various control under each category. Let's break down the network security controls for server security in a way that is easy to digest, even if you are not a nib-d in tech lingo. There are 5 key network controls that you should consider for server security as shown on the screen, and each control is customer responsibility. Let's discuss each of them. For protecting Azure resources within virtual network, slap an energy on every network where your VMs live. Think of this as the bouncer who only lets in people on the guest list. You can also set up a centralized guard, such as like Azure Firewall, if you prefer a more centralized defense system. Or you may end up with centralized firewall and energy to protect your virtual network. For monitoring and logging the configuration and traffic of virtual networks, subnets and network interfaces, use Microsoft Defender for Cloud as your surveillance system. It will keep an eye out and suggest improvements. Turn on energy or virtual network flow logs to records who is coming and going. Then store those logs in a secure vault, such as like a storage account for future investigations. For protecting critical web applications, for extra security, you can deploy Azure Web Application Firewall, which checks everyone's ID at the door and ensure no troublemakers get in. Don't forget to turn on the logs for WAP so you can review who tried to sneak in. To deny communications with known malicious IP addresses, enable data standard protection to guard against massive attacks like building a moat around your castle. Use Microsoft Defender for Cloud's threat intelligence to block any known baddies. Also limit who can access your VM, and only for short periods with just-in-time network access. If the system detects anything suspicious, it can adjust your defenses automatically. For recording network packets, record energy flow logs to see detailed record of who is being around. If someone doesn't seem right, use Network Watcher to capture network packets, which lets you review exactly what kind of traffic was happening. And remember, who is in charge of all these controls? You as a customer and not cloud provider. Let's dive into how you can keep your server secure through identity and access controls and make sure only the right people have the right access. First control in the list is maintain an inventory of administrative accounts. Think of administrative accounts as the keys to the kingdom. You need to know exactly who has these keys and make sure there aren't too many floating around. You can use Microsoft Entra ID to manage who can access what. But remember, Azure virtual machines can also have local accounts. You should keep track of both local and domain accounts and keep them to a bare minimum. For those really important keys, such as administrative account, use Azure Privilege Identity Management. PIM lets you monitor and manage who can do what with these accounts and ensure only the right people have access and only when they really need it. Another consideration is change default passwords where applicable. Default passwords are like factory set keys. Anyone knows them, so they are not secure at all. While Windows virtual machines and Microsoft Entra ID don't come with default passwords, if you are using other applications or services from the marketplace, you might have some. Change those default passwords ASAP to something unique and secure. Don't leave those factory set keys lying around. You should also use dedicated administrative accounts. Imagine having a special key that only opens certain doors. That's what a dedicated administrative account is. A key that's only used for specific high-level tasks. You can set up dedicated administrative accounts and stick to them for administrative tasks. Don't use your everyday account for these high-level jobs. Microsoft Defender for Cloud can help you keep an eye on how many these special keys you have. Also use Azure PIM to manage these accounts, which enable things like just-in-time access, multi-factor authentication and approval processes. You can use Microsoft Entra single sign-on rather than juggling a bunch of different keys for different doors. Wouldn't it be easier to have just one key that works everywhere? That's what single sign-on does. Whenever possible, set up Microsoft Entra SSO so you don't have to manage separate credentials for each service. It simplifies access and makes it more secure. Microsoft Defender for Cloud can provide recommendations to make sure your identity and access management are on point. You should also use multi-factor authentication for all Microsoft Entra ID based access. Even if someone gets hold of your key, multi-factor authentication is like having a second lock on the door. They will need more than just your password to get in. You make sure MFA is turned on for all access that uses Microsoft Entra ID. This adds an extra layer of security, which makes it much harder for anyone to break in. Follow the recommendations from Microsoft Defender for Cloud to ensure you are fully protected. And remember again, who is in charge of all these controls? You as a customer and not cloud provider. Let's break down server security focusing on data protection. There are 5 key controls in this case as well, as shown on the screen. First control is keep track of sensitive information. Think of this as keeping an organized list of all your most valuable items. For servers, this means knowing exactly where your sensitive information is stored. You can do this by tagging your virtual machines that handle this kind of data. It's like putting a label on a box to remind yourself what's inside. This way, you always know where your sensitive stuff is, making it easier to protect. Second control is separate and isolate sensitive systems. Imagine you are running a bakery. You wouldn't mix the ingredients for a birthday cake with those for an experimental recipe, right? Similarly, for your servers, it's crucial to separate environments like development, testing, and production. You can do this by setting up different subscriptions or management groups. And just like keeping different dishes in a separate sections of your kitchen, you should use virtual networks, subnets, and security groups to keep things isolated. Plus, turn off the VMs storing sensitive data when you are not using them, just like you would turn off the oven when you are done baking. Third control is monitor and block unauthorized data transfer. Think of your server as a treasure. You wouldn't want someone sneaking in and making out your gold coins unnoticed, right? Here you need to set up a guard at the network border. This means using tools that keep an eye on your data. If they spot any unauthorized transfer attempts, they should block it and immediately alert you. It's like having a security system that logs down and rings an alarm if someone tries to walk up with your treasure. Fourth control is encrypt sensitive data in transit. When you send a letter, you don't want anyone reading it along the way, right? The same goes for your data when moving from one place to another. Encrypting data in transit is like sealing your letter in an envelope and marking it as confidential. Microsoft helps here by using the TLS protocol, which acts like that envelope, and ensure your data stays private as it travels between your cloud services and your customer. Note, this is a shared responsibility. Microsoft handles some parts, but you also need to make sure your side is secure. Fifth control is actively discover sensitive data. This is like having a detective who regularly checks your house to make sure no valuable items are lying around unprotected. Use a discovery tool to scan your technology systems and identify any sensitive information you might have missed. This tool helps keep your inventory up to date so nothing slips through the cracks. And remember, who is in charge of all this control? You as a customer and not cloud provider. Encrypt sensitive data in transit, as I mentioned, is a shared responsibility though between you and cloud provider. Let's dive into vulnerability management for server security in a way that's straightforward and easy to understand. First control is run automated vulnerability scanning tools. Imagine your server as a house and you want to ensure that there are no weak spots where intruders could break in. To do this, you regularly scan the house for vulnerabilities, like checking if windows are locked and the alarm system is working. In the world of servers, this is done using automated vulnerability scanning tools. Microsoft Defender for Cloud is like a highly recommended security inspector that helps you run the scan on your Azure virtual machines. You can also choose to use another tool if you prefer, but the goal is the same. Regularly check for any security weaknesses. Second control is deploy automated operating system patch management. Once you have found any vulnerabilities, the next step is to fix them. This is where patching comes in, like repairing a broken window or reinforcing a door. For your servers, you can use the Azure Update Management solution, which automatically manages updates and patches for your VMs. It makes sure that the operating system is up to date and protected against known vulnerabilities. It's like having a handyman who regularly comes in to fix any issues. Third control is deploy automated patch management for non-Microsoft software. Now your server doesn't just run on Microsoft software. It might also use tools from other companies. These also need to be kept up to date. Just like you wouldn't only fix the front door and leave the back door vulnerable, you need to patch non-Microsoft software too. You can use the same Azure Update Management solution or another patch management tool to handle this. It ensures that all software, not just Microsoft ones, is regularly updated and secured. Fourth control is compare back-to-back vulnerability scans. After you had done your scans and patches, it's important to check that everything is actually fixed. This is like doing a final walkthrough of your house to ensure all the repairs are in place. In server security, you would export the results of your vulnerability scan at regular intervals and compare them over time. This lets you see if the issue you found earlier have been resolved. Microsoft Defender for Cloud helps with this by allowing you to view historical scan data and track your progress. Fifth control is use a risk rating process to prioritize vulnerability remediation. Not all vulnerabilities are quite dangerous. Some are like leaving a window open, risky but not immediately critical. Others are like having no lock on your front door, something that needs to be fixed right away. To help you prioritize, Microsoft Defender for Cloud provides a CQ score which rates the risk of each vulnerability. This helps you decide what to tackle first, so you can address the most serious issues before moving on to the less critical ones. And remember, who is in charge of all these controls? You as a customer and not cloud provider. Let's break down the server security with a focus on inventory and asset management. First control is use automated asset discovery solution. Imagine you are managing a large warehouse filled with all sorts of valuable items. To keep track of everything, you would want an efficient way to scan and discover every item inside. For your servers and cloud resources, this is where an automated asset discovery solution comes in handy. In Azure, you can use the Azure Resource Graph, which is like a powerful scanner that helps you query and discover all the resources, including virtual machines within your subscriptions. But remember, you need the right permission to see everything, just like you would need access to every part of the warehouse to do a complete inventory. Second control is maintain asset metadata. Once you have found all your resources, the next step is to organize them. Think of this as labeling boxes in your warehouse with detailed information, so you know exactly what's inside each one. In Azure, you can apply tags to your resources. These tags are like labels that help you logically organize everything according to a system or taxonomy that makes sense for your business. Third control is delete unauthorized Azure resources. Just like you wouldn't want unauthorized items cluttering up your warehouse, you don't want unauthorized resources hanging around in your Azure environment. This could pose a security risk or simply add unnecessary clutter. To keep things tidy and secure, you should regularly reconcile your inventory. This means checking what you have and removing anything that shouldn't be there. Tagging, management groups, and separate subscription can help you keep track of everything, which makes it easier to spot and delete unauthorized resources quickly. Fourth control is define and maintain an inventory of approved Azure resources. It's important to know exactly what's allowed in your environment. Think of this as having a list of approved items that are permitted in your warehouse. For Azure, you should create an inventory of approved resources and software. You can take it a step further by using adaptive application controls in Microsoft Defender for Cloud, which lets you define which applications are allowed to run on your machines. This way, you are not just keeping an eye on what's in the warehouse, you are also controlling what can happen inside it. Fifth control is monitor for unapproved Azure resources. Finally, it's crucial to keep an eye out for anything that shouldn't be there. This is like having security guard checking to make sure only approved items are in your warehouse. In Azure, you can use Azure policy to restrict the types of resources that can be created in your subscriptions. With built-in policy definitions like not allowed resource type and allowed resource type, you can set clear boundaries. Additionally, Azure Resource Graph can help you regularly query and discover resources, which ensure that no unapproved resources slip through the cracks. And remember, who is in charge of all these controls? You as a customer and not cloud provider. Let's break down secure configuration for server security. First control is establish secure configurations for all Azure resources. Think of your server setup as building a secure house. The first step is to ensure that every part of the house, from the doors to the windows, is set up correctly to keep intruders out. For your Azure resources, this means establishing secure configurations right from the start. You can use Azure Policy or Microsoft Defender for Cloud to keep these configurations in check. These tools are like Security Inspector who make sure everything is up to standard. Azure Resource Manager can also export templates in JSON format, which you should review to ensure they meet or exceed your company's security requirements. Second control is establish secure operating system configurations. Just like a house needs strong walls and a reliable roof, your server operating system needs to be securely configured. Microsoft Defender for Cloud provides recommendations such as remediate vulnerabilities in security configurations on your virtual machines to help you maintain strong security on your compute resources. This is like getting a checklist from a security expert on how to fortify your house structure. Third control is maintain secure Azure resource configurations. Security doesn't stop after the initial setup. You need to regularly maintain secure configurations for your Azure resources, much like doing routine maintenance on your house to keep it safe. ARM templates and Azure policies help you enforce secure configurations for your virtual machines and associated resources. ARM templates are like blueprints for your VM setup, and using policies like deny and deploy if not exist ensures that secure settings are consistently applied. Fourth control is maintain secure operating system configurations. To keep your server's OS secure over time, there are several options you can use. First one is ARM template. These are JSON-based files that will help you deploy VMs with secure configurations right from the Azure portal. Second one is custom virtual hard disk. For complex environment that can be managed through the standard methods, you might need custom VHDs. Once your OS is deployed, Azure Automation State Configuration tool allows you to have more granular control over settings, ensuring they stay secure. For most scenarios, combining Microsoft-based VM templates with Azure Automation Desired State Configuration will help you meet and maintain security requirements. This is like having a combination of pre-built secure walls with custom enhancement where needed, plus ongoing monitoring to secure everything stays in place. Fifth control is securely store configuration of Azure resources. Finally, all the configuration you have set up need to be stored securely, just like you would keep your house blueprints in a safe place. Azure Repo is the tool for this job. Securely storing and managing your code, including custom Azure policies, ARM templates, desired state configuration script, and many more, Access to these resources should be tightly controlled with permissions granted through built-in security groups in Microsoft Entra ID or Active Directory. And remember, who is in charge of all these controls? You as a customer and not cloud provider. Let's dive into server security with a focus on malware defense. First control is use centrally managed anti-malware software. Think of your server as a fortress and malware as the sneaky invaders trying to breach your walls. To keep them out, you need a robust defense system. For your Azure Windows virtual machines, Microsoft Anti-Malware act like a vigilant security guard, continuously monitoring your resources and defining them against malicious threats. This centralized management ensures that all your virtual machines are protected without you having to micromanage each one. Second control is pre-scan files to be uploaded to non-compute Azure resources. Imagine you are receiving a package at your fortress. Before bringing them inside, you would want to check for hidden dangers. Similarly, when files are uploaded to non-compute Azure resources like app service, data lake storage or blob storage, this should be pre-scanned to ensure they are not carrying any malware. You can use Azure Defender for storage to automatically detect and alert you to any malware trying to sneak into your storage accounts. Third control is ensure anti-malware software and signatures are updated. Your defense system is only as good as its latest update. Just like a security guard needs the latest training to handle new threats, your anti-malware software needs to be set up to date with the latest signatures, platforms, and engines to combat evolving malware. When you deploy Microsoft Anti-Malware for Azure, it will automatically install these updates. Additionally, you should follow the recommendations in Microsoft Defender for Cloud under Compute and Apps to keep all endpoints current. To add an extra layer of security, you can use Microsoft Defender Advanced Threat Protection, which integrates with Microsoft Defender for Cloud, further safeguarding your Windows OS from virus or malware-based attacks. And remember, who is in charge of all this control? You as a customer and not cloud provider. Let's break down server security with a focus on data recovery. First control is ensure regular automated backups. Imagine your server is like a valuable treasure. To make sure you never lose anything important, you would want to make copies of everything inside. Just in case something happens in the digital world, this means setting up regular automated backups by enabling Azure Backup. You can configure your Azure virtual machines to automatically back up data at regular intervals based on your desired frequency and how long you want to keep these backups. Second control is perform complete system backups and backup any customer managed keys. Backing up your server is like making a full copy of your treasure, including every key and secret code you use to protect it. This means creating a complete system backups, including all the data and configurations on your Azure virtual machines. You can use tools like PowerShell or REST API to create snapshot of your VMs or the managed disk attached to them. Additionally, any customer managed keys stored in Key Vault should also be backed up. If you are using Azure Disk Encryption, Azure VM Backup will automatically handle the backup of these keys and ensure that even your encryption tools are safely stored. Third control is validate all backups including customer managed key. It's not enough to just make backups. You also need to make sure they actually work. This is like checking your treasure copies to ensure they are complete and not missing anything. You should regularly validate your backups by performing data restoration test. This might involve restoring data to an isolated virtual network or subscription to ensure everything works as expected. If you have backed up customer managed key, you should also test restoring them. For those using Azure Disk Encryption, make sure you can restore your Azure VM with the disk encryption keys intact. Fourth control is ensure protection of backups and customer managed keys. Backing up your data is one thing, but protecting those backups is just as important. Think of this as locking your treasure copies in a safe. When you back up Azure Managed Disk with Azure Backup, the VMs are encrypted at rest using storage service encryption. If you are using Azure Disk Encryption, Azure Backup will also back up these VMs and safeguard the encryption keys within Azure Key Vault. To add an extra layer of protection, Azure Disk Encryption integrates with BitLocker encryption keys and Azure Key Vault key encryption keys. You can enable soft delete in Azure Key Vault to prevent keys from being accidentally or maliciously deleted, which gives you peace of mind that your backup and keys are securely protected. And remember, who is in charge of all these controls? You as a customer and not cloud provider. Let's dive into security controls with a focus on logging and monitoring. First control is use approved time synchronization sources. Think of time synchronization as making sure all your logs are set correctly. For Azure resources, Microsoft ensures that time is synchronized accurately across the board. However, for your Windows virtual machines, you have the option to manage and configure time settings to keep everything in sync. Proper time synchronization is crucial for accurate logging and monitoring, as it ensures that all events are recorded with the correct timestamp. Microsoft takes care of time synchronization for Azure resources, but you can manage it for your Windows VM and Linux VM. Second control is configure central security log management. Imagine you have a security camera system watching over your server. All the footage it captures needs to be managed centrally to keep track of everything that happens. Microsoft Defender for Cloud provides security event log monitoring for your Windows VM, helping you manage these logs. However, due to the sheer volumes of data generated, logs aren't stored by default. You will need to decide what's important to keep and configure accordingly. Third control is enable audit logging for Azure resources. Audit logging is like keeping a detailed journal of all changes and actions taken on your server. Activity logs in Azure captures every operation performed on your VM resources, like creating, updating, or deleting resources. This is incredibly useful for troubleshooting errors or tracking how users modify resources. Additionally, you can collect diagnostic data from your VM using the diagnostic extension. And for more in-depth monitoring, tools like Azure Monitor for VMs and application insights can be enabled. These tools help you keep an eye on your applications, capturing telemetry data like HTTP requests and exceptions, so you can connect the dots between issues in your VMs and applications. Control collect security logs from operating system. Your server's operating system generates security logs that record important events, much like how a security guard keeps a log of everything that happens on their watch. Microsoft Defender for Cloud helps monitor these security event logs on your Azure VM. However, due to the high volume of data, these logs aren't stored by default. If your organization needs to keep these logs, you can store them in Log Analytic Workspace. This allows you to retain the security event logs for as long as necessary, according to your organization's requirement. Fifth control is configure security log storage retention. Once you have decided to store your logs, it is important to ensure they are kept safe and accessible for the right amount of time. This is like setting the rules for how long your security footage is kept before it is archived or deleted. You need to make sure that any storage account or log analytic workspace used for storing your VM logs have a log retention period that aligns with your organization's compliance regulations. And remember, who is in charge of all these controls? You as a customer and not cloud provider. With this, we just discuss all the security controls, for the server hardening and server security.